Hey guys, it's Connor and you're watching the JavaScript Mastery series. Now in this video, we're diving into all of the different types that exist in JavaScript. You'll learn that every type falls into one of two categories, primitives or references. First, we'll break down primitives, what they are, which types fall under this category, and what exactly it is that makes them primitives. Then we will explore reference types, how they work, what types fall under this category and makes them references. Then finally, we will look at the difference between primitives and references. And by the end, you will know the difference between them and also understand why knowing the difference between them is so important in the first place. Now, this concept can be quite tricky and a lot of developers get this wrong. But don't worry, I'm going to be breaking it down and making it super simple and easy to digest. This video is going to be ranked a blue belt. So we're going to be keeping it beginner friendly and making sure everything is as easy to understand as possible. Okay, let's get started. So what exactly is a primitive? A primitive is a basic immutable value that is stored directly in memory. I know, that was a lot of technical jargon. It might sound complicated, but stick with me. I promise we're going to break it down, and by the end of this segment, you will get it. So let's break this down into parts. So the first thing that we said was that a primitive is basic. Now, when we say a primitive is a basic type, all we mean is that it's simple. It doesn't do anything fancy. It's just a value. That's why it's called a primitive, because it's basic. It doesn't have any special behaviors. It just stores a value, and that's it. That's literally it. Now, to understand this better, let's look at the primitive types in JavaScript. You've probably already seen them before. So I am using Cursor AI. So hopefully with a few comments. So we've got primitive data types. So we got, let's see, we got hero, which is a string. So we've got a string, we've got a number, we have Boolean values, we have null. So let started equals null. A null is a primitive, and undefined is a primitive. A symbol is a primitive, and look, not quite so new anymore since ES6, but a big int is primitive. So these are all the different types in JavaScript that are primitives. Now, a simple way of thinking about it is, in JavaScript, anything that is not an object is a primitive. So in JavaScript, an array is an object, a function is an object, and of course an object is an object. So anything else outside of those are primitive. Now, the second thing that we said was primitives are immutable. What does that mean? I know immutable sounds like a fancy word, but all it basically means is it cannot be changed. Once you assign a value, that value does not change. It never changes. Now, you might be thinking, well, I can update a variable that holds a primitive, right? But doesn't that mean I'm changing it? Well, not quite. You see, when you reassign a variable, you're not actually changing the original value. Instead, what you're doing is you are changing the value stored inside that variable. So for example, if I had let hero equal Batman, and then I change this value to Superman, I never actually changed this value in any way. All I did was I changed the value being stored inside of this variable hero. Now, a slightly easier way to think of this is with an image. So if we think of our variable as a container that holds our value, and we think of the variable name as like a label for that container, call that hero, and the value stored inside of this container is going to be Batman. When I reassigned the value Superman to this variable, I never actually changed this value. I never edited it in any kind of way. Instead, this is what happened. We created a new value, we called it Superman, and then what we did was we just changed the value inside of the container to now hold Superman, but this original value Batman is still there, it still exists. If you could peek your head inside of the JavaScript memory somehow, you would still see this here. It's just that the container no longer holds it, it's holding Superman. So we never edited or changed this in any way. All we did was change the value being stored inside of that variable. And this is what we mean when we say that a primitive is immutable. We can't change it. Even if we change the value of a variable, we're just swapping out the value of that variable being stored. Now, the third thing we said was a primitive type is stored directly in memory. But what exactly does that mean? I mean, doesn't everything get stored in memory? To really understand this, we kind of need to compare it to reference types, which we will cover soon. But first, let's just look at this in a little bit more detail and see what we mean when we say a primitive is stored directly in value. So let's say you assign a primitive value to a variable. Then you create another variable and assign it the value of the first variable. You know what, let's make sure, let's follow along. Let's say I have this value here, hero equals Batman. Now let's say I create another hero. I'm gonna call it hero 2. And I'm gonna assign hero 2 to the value of hero. Now when we log this out, and then I'm going to execute this script. So as you can see, hero equals Batman, hero 2 equals Batman. Now if I decide I want to change the value in hero 2, so hero 2 equals Robin. Now when I run this, okay, hero is still Batman and hero 2 is still Robin. So that's pretty straightforward. Okay, so let's take a look at this in more detail. So let's make that line 1. So on line, we create a variable called hero. So here's what this would look like. You have your container and we've assigned it the name hero, and it's currently it currently stores the value Batman. Okay, now when we on line 3, we created a new variable called hero 2 equals hero, and here's what's happened. So now, so it's got a new container, and when hero 2 equals hero, it doesn't just point to this value like this, because that would be pointing to the reference of that value. That means that both these containers would be sharing this value, but that is not what happened. So on line 3, when hero 2 equals hero, what JavaScript did was it created a copy of this value. It created a second value called Batman. Then this container got stored the value. So on line 3, there's Batman and there's a copy of Batman. So if you could peek your head into JavaScript's memory, you'll see two values, right? Because it's a primitive, it stores its own copy of this value. And that's why on line 5, if we was to change this to Robin, of course, let's give this a label so it makes a bit. So we go hero, this is now called hero 2, fine. Then when I change this to Robin, I'm not changing this one in any way. I change the value being stored in this container to Robin. Then this has its complete own value. No matter what I do to this, it won't impact this variable. And this one, I can change this to whatever I like, and this won't impact this variable because they both hold their own copies of their own values. And this is what we mean when we say that primitives create a copy of the original value and store it in a new variable. Every primitive type is stored independently, meaning each variable holds its own separate copy of the value, right? We assigned hero2 to hero and we copied that value. We never shared it. It was stored independently. Now, as primitives store values, when they get compared by their values as well. So when I do hero and I compare it to hero2, let's go the same hero, and then let's run this script. It says the same hero false. One's Batman, one's Robin. So if we change hero2 to Batman, they both store the same value, both independent of each other. But when we compare their values, true. This holds Batman. This holds Batman. When primitives are compared, they are compared by value. Both of these values are the same. So reference types, what are they? Well, a reference type is anything in JavaScript that is an object. Now, arrays are objects, functions are objects, and of course, objects are objects. Unlike primitive types, reference types have properties and methods. Now, that doesn't quite make total sense, since we will see that primitives can have methods and properties, but this is because of some of JavaScript's secret magic that allows us to use primitives as if they were objects and use methods on them. But more on that later. Now, here's something really important. Reference types are mutable, right? We said primitive types are immutable. Reference types are mutable. That means we can change them. Even if we use a const to assign a value to a reference, we can't reassign a value to the object, but we can change the properties on that object. So let's take a look at what that looks like. Okay, so const hero equals name equals Batman. AI is doing its thing, super useful. Okay, so fine, we have this object. Now, even though we use the const, what we can do is we can mutate its properties. We can change them, right? So const, as you can see, only prevents reassignment, right? If I try and change hero to something completely different, and then we try to run that again, error, right? Try to assignment to a constant variable. We can't reassign it. We can only mutate the properties on it. Now, when we assign a primitive value to a variable, that variable stores the value directly in memory. But when we assign an object, which is a reference type to a variable, the variable does not store the actual object. Instead, it stores a reference to where the object is located in memory. Now, that is a huge difference. Now, let's take a look at what this looks like, right? So we've seen, so these are our primitives, but let's say this is an object and it looks like this. So this is our variable and it's going to hold an object. Now let's say we create a new variable, hero2, and assign it to hero. Now with primitives, when we do this, when we assign the value of one variable to another, it creates a copy. But with objects, that is not what happens. Instead, if this is an object, I forgot to relabel this, and then we create hero2. On line 10, here, when we assign hero2 to hero, here's what's actually happening. It's not creating a copy of this value. It's not doing this and creating its own value to be stored in that container. That is not what's happening. Instead, what it's doing is, on line 10, when hero2 equals hero, it's being assigned a reference to that object. And this is why it's called a reference type, because they don't store their own values. Instead, they store what you might call like a pointer. In another language, it's like it's storing a reference to a place in the memory, which is where this value exists. Okay, so primitives store values, reference types store references, and this matters in scenarios like this when we assign one reference to the value of another. Now watch what happens when I change the original value of hero. So we've got hero2 equals hero. Okay, we go Joker. Then we're going to console.log hero, and then we're going to console.log hero2. Typo. Now look at hero2. Right, we never changed hero2, but as we can see, it's had its name changed. And the reason is because when we changed the original value in hero2 still points to that value, because they both share that value. They both point to that same value, right? Because they only hold references. So on line 13, when we changed hero name to Joker, hero, we changed this variable, we changed it to Joker. Look at hero2, it doesn't have its own copy of this value, right? It's still referencing that original value. And that is why when we logged out hero2, we could see that this name changed as well, because they both hold a reference to the same value. So when we change it for one, we change it for the other. Now let's look at hero2, and let's change the age to 32. So we've just changed hero2. Let's see what happens. As you can see, look, it's also changed for hero, right? We changed hero2 on line 15, but the value also changed to hero. That's because, again guys, we changed hero2 here, and hero also changed because both reference types point to the same value. They don't have their own copy. They're both pointing to the same one. Now then, how does this affect comparisons? Now we saw with primitives that the values were compared by value, right? So let's take a look at that one last time so we know what that looks like. So we did this, Robin, and then we also said this was Robin. Now when these because these hold values in their containers, when they get compared, the same psychic equals true, right? They're being compared by their value. Now let's say, let's tidy this up a little bit. It's getting a bit messy. Okay, now let's do the same thing for hero, right? So hero2, look, these both have the exact same values, right? You just watch me copy and paste it. Console.log, the same hero. Now let's see what happens. Oh, what happened? They're both the exact same value. Now, not only do reference types store values differently than primitives, but they're also compared differently as well. They're compared by their references, not by their values. Now the best way to think about this is comparisons get stored by what's inside of their containers, right? So with the primitives, they both store values, right? So by two values, this holds a value, this holds the value. They both hold their own values. These do not hold their own value. They hold the references to the same value. So Batman and Batman. Hero2. Okay, so and then these get compared and they're both the same value. Now with reference types, remember when they're being compared, they don't actually hold their own value, right? They hold a reference to a value, and that is what they get compared to. They get compared by their reference. So we've got const hero. Now if we assigned hero2 to hero, so exact same values, right? But we've assigned it. As you can see, now it's the same hero. So when it got compared by its values, they were false. But when they got compared by their reference, they were true. And here's why. If you just go back here, when I created hero2, this got assigned its own value. Completely separate from this, it created its complete own value. So at the time it looked like this, right? Because we created its own value. Now these containers don't technically hold values, they hold reference to values. Now let's see if we can find something that makes that easy to look at. So here's a value, and this here is going to be a reference to that value. It's going to point to where it exists in memory. It's going to look something like that. Now just pretend this is our reference to this value. This variable hero is a reference type, and it contains the reference to this value. Okay, now pretend this arrow is a reference. Now then, same thing for this one. My goodness, I have made a mess. This also has a value that points to this oh my goodness, what's going on? Right, so it really looks like this. That's the value. The reference is holding a reference to that value. This is holding a reference to that value. When these get compared, JavaScript saying, look, these references aren't the same. They're both pointing to a different place in memory. You're pointing to, let's make up a name for the memory, grid 1-2. You're pointing to grid 110. You're not the same. Now, if I was to assign hero 2 to hero, what's happening is this is being assigned to the exact same reference, right? Because we said hero 2 on line 9 equals hero. So this way, when this happened, we assigned hero 2 to the same reference as hero. And now both of these containers store the same reference to the same value in memory here at, say, grid 110. So now when we compare these two, they are true because they both contain the same reference to the same place in memory. References are compared by their reference and what they point to in memory, not their value, whereas primitive types are compared by their value. So guys, we learned what primitives are, and hopefully by now you've got a solid grasp of what it means when we say a primitive is a basic immutable value that's stored directly in memory. And now next time you hear those words, you're not feeling overwhelmed. You actually get what it means. We also dug into reference types, why they're called references, how JavaScript stores them differently from primitives, and how that affects not just how values are stored, but also how they are compared. Now, you might be wondering, why does this even matter? I mean, it's all happening under the hood. Why is it so important to understand this stuff on a fundamental level, especially when you're just trying to earn our blue belt in coding, right? At such an introductory level where we're just trying to get to an entry level, whether that be a graduate or you're going for your first junior role. But well, here's why. The concept directly affects how we solve problems in a code base, and that's a big deal for us as engineers. Think about it, right? If you store a value, then assign it to another variable, you could unintentionally introduce a bug if you don't fully understand whether you're dealing with a primitive being copied or a reference being shared. One small change that can ripple across your code base in ways you didn't even expect, just because you misunderstood how the value was being handled. Even in a junior or entry level role, you're going to be expected to understand these concepts. If you don't, it's easy to create subtle, hard to catch bugs. But mastering this concept and really getting to terms with these technical jargon really shows and demonstrates a level of professionalism. It tells people you're not just writing JavaScript, you actually understand it. So that's all from me, guys. I hope you liked the video. If you got any value of it, please like it and stay subscribed so you get notifications when I drop the next one. See you guys.